Okay, so I'm going to touch on some of these concepts here in grounding and bonding. Again, and also looking at the layout of the actual section itself. Again, read through different objectives. Go through, again, if it mentions a rule, go check it out. Again, this is the general portion. We'll just look at this section here right now. Just kind of get a feel for it. Again, there was a rewrite of this section in this edition of the code. So section 10, grounding and bonding, scope, object, special terminology. So this is the rule right here. Tells you the different objectives between being solidly grounded, using an impedance grounding system, ungrounded, and the point of bonding. Okay, and then there is some special terminology here too. So if you don't have an understanding of some of these terms, definitely read through them. They're going to be using them throughout the rules specifically. So make sure that you do have an understanding of these terms and what they are as well too. So again, the different layout here, they talk about grounding. Again, grounding in general starts out with electrodes, okay, the portion of the ground that's in the ground. Goes through different type of material for grounded conductors, continuity, grounded conductor sizes. Okay, number 6, that shall not be smaller than these. Okay, installation, how we're going to install them. Again, the different types of systems, the grounding for them. Okay, the grounding for impedance ground here. And then ungrounded systems as well. Okay, so it does cover all that, and then it gets into bonding. Okay, so it's kind of nice where they've got it where we talk about grounding, get that kind of taken care of, then we talk about bonding. It does make it a little easier when we're kind of searching and trying to find a rule. So in the bonding, talks about equipment bonding, bonding at other than service equipment. So just make sure you're really reading the question. Okay, so this one says bonding continuity for service equipment. So you just come to this rule specifically for service equipment. Okay, watch out here too when they have these sub rules. Make sure you're reading whether they are and, or in some aspects or examples they're an or. Obviously that's a huge difference. If it's an and, all the rules have to apply. If it's an or, it depends on the scenario that you're dealing with. Okay. Size of system bonding jumpers, again, system bonding jumper or bonding conductor. So all your bonding sizes are going to happen here. It just depends on which rule. This one here is for system bonding jumper, and I have these underlined because then it's easier for me. By all means, do the same. Bonding conductor, field installed bonding conductor. Okay, this one is at service equipment. And the other one is other than service equipment. Okay, so really make sure you're reading carefully, is what I would say. Equipotential bonding, following parts of non-electrical equipment shall be made equipotential with the non-current carrying conductive parts of equipment. Tells you the things that we need to basically bond that aren't necessarily electrical equipment, because we do have that issue as well too to deal with. Again, and then their conductor sizes too. So yeah, we do have, like in a house, we bond our gas line. If your house had copper water lines, you could bond those as well, because otherwise if they get in contact with a live wire, now they are alive. Okay, if we bring it to the same potential as ground, it will arc and trip instead. Again, safety is why we're doing this mainly. So that's kind of the layout of the section 10. Again, not too terrible. Some would argue, say it's better than it was. Depends if you had experience or not with the other one. It's definitely laid out a lot better, I would say. So then our module kind of follows suit. So we talk about grounding for systems and circuits. Starts with the DC. Again, this is the first rule at 10.200. Under solidly grounded, starts talking about DC systems. Then AC systems required to be solidly grounded. Okay, but again, go through this again. This stuff is not too terrible to read. It'll tell you what needs to be grounded, and then show you the rule and relate to the picture. Okay, so definitely make sure you're reading through your module with this stuff too. They do have good diagrams and stuff in the module themselves. Some of them are also, there's something equally represented in the appendix. So the appendix is actually decent in section 10 too. So I'll just flip there quick so we can show you guys that as well too. Again, we won't have our modules with us when we're writing a test, but we will have our code book, so take advantage of that. And, well, I guess here at the beginning even, when we first start talking about the section 10, this is in the appendix now. It'll go through the rules, obviously, 002. It's going to talk about the term bonding and how it's used and what equipotential means. Okay, going to go a little bit more detailed than what the rules are just specifically saying. Definition of the grounded conductor. Okay, used to refer to the conductor of an electrical system that is grounded. Okay, not too terrible. But it does have a lot of extra information again, as opposed to what's just in the in the rule itself. So one of the diagrams that they do reference is pretty much the same kind of deal as what we have in the module. Okay, so this one here is showing us that if we have two places that we can bring our grounded conductor to, either in the meter or in the service box. So this is showing in the meter. If we came here, if we grounded our grounded conductor at this point, and we can only do it at one point, and we have an isolated, in this case, an isolated neutral bus, which just means that this bus is not touching the back of the enclosure. It's on standoffs and isolated. That we would have to see the system bonding jumper, okay? Because now we still need to bond everything back to ground. So this can either, they talk about here, can either be a screw, potentially a field installed bonding jumper, or even a strap from the factory. Okay, so we still need this. But again, this can only happen at one point. So if it happens here, we can't have it in the panel or in the service box. So this kind of even shows a little better because it shows the same thing where we have our ground connection here. Again, on this neutral bus, this would be isolated. And then we have this jumper. Again, system bonding jumper could be a screw, could be factory installed or installed by an electrician. Then here's our bonding conductor coming from the bonding bus now across and down to our panel. So we don't have another connection to our grounded circuit conductor to ground after here. We have our grounded circuit conductor coming through, connecting on our neutral bus, and then continuing on to our loads. This now needs to be isolated. Okay, so there's a screw that's touching this bus to the back of the enclosure. We take that screw out because we can't have this making a connection to ground at more than one place. Okay, and then they talk about the other scenario, and they do in your module too, but this picture's right on the next page. This is where we're grounding it in the service box instead. And still, one connection at the grounded circuit. So when we go back here, again, now we're isolated here. So if there was a screw, we'd take it out there. Our bond is, system bonding jumper now is happening in this portion here because this is where the grounding is taking place. Then we have our system bond, still referred to as a system because it's where our grounding is taking place for our system. Then we carry a bond back so that this enclosure is bonded. You used to be able to just bond it here by not isolating this, and this is one of the rules that changed. So we would have to bring a separate bonding conductor back to that meter base so that that enclosure was actually bonded as well. If not, if we didn't bring that bond through and this was isolated, now if this enclosure for some reason gets a hot wire touched to it, now this thing is live. Okay, if it's not bonded to ground, then we got a potential issue, obviously an extremely dangerous issue. So we do have to carry that bond back now. So again, those pictures, I think they're extremely helpful, especially when trying to understand these connections, but also the fact that it's in the code. Okay, so I write them down here if I ever need to reference them again. Here's the way they show it in the module. Again, probably not quite as nice and clear, I'd say, as the other ones in the code, but nice quick representation. And then I talk about impedance grounded system. Again, we did talk a bit about this in third year. Basically, we're going to limit the fault current through an impedance grounding system. We could be doing that. Basically, we want to know that there's a fault, but we potentially don't want to shut down a main breaker or a whole system at a plant or something like that. We may not want that fault to actually open a circuit if there's a process running that could cost millions of dollars or create potentially another hazardous situation. So we do have these systems as well. Again, read through, check the rules. It'll go through the code. Again, fairly straightforward. Same with ungrounded. Has to be monitored. Okay, these things. It even says, it seems crazy that we wouldn't have it now, but it says if one ground fault occurs on an ungrounded system, it can continue its operation without an overcurrent device tripping. In such an installation, the CEC requires a ground fault detection device that notifies plant staff of the fault situation. Okay, so just because we don't have it, we still need to know it's happening, okay, in these specific types of systems. So go through and it will definitely get you up to speed on those different types and reference some of the rules. Again, goes back now, starts with grounding in general, again, for all these things. So solidly grounded, again, at one point only, either the service box or the meter mounting device. So that's what it's going to go through. The grounded conductor is connected to the equipment bonding terminal by the system bonding jumper. So it's telling you what it is, it's referencing the rule, and continues to do that. Okay, and then provides some pictures. But if it's got a rule that says there's an appendix attached to it, go to the appendix too and check it out, because it's probably gonna have a better picture, I would say. And then again, at least you have this reference for when you're writing tests. Again, here it says 210 D and Appendix B state the grounded circuit conductor on the load side of the service disconnecting means shall not be used for bonding equipment. It is therefore required to remove the bonding screw or jumpers connected to the grounded circuit conductor or neutral bar on the load side of the service disconnecting means. So again, if we're grounding our system here, we cannot have another connection for this grounded conductor and ground. Okay, so we have to remove that bonding screw to isolate it on the load side, because it says we cannot have it at more than one location. Okay, so things like that, and they really hammer this stuff home. Separately derived systems, so this is like you have a service and then potentially you have a transformer. I've had these installations in like welding shops where you have, certain voltage coming in, but you need a different voltage for a piece of machinery or something. Tells you how to deal with that to a point where if they're separately derived but 750 or less, we can actually don't have to pull a separate ground through there. We can use the bond, okay, based on certain conditions. Same deal with this one too, just a different scenario. But we're using the system bonding jumper, and it says that we can do this. Again, as long as we stay within these restrictions, where we wouldn't have to drop another separate ground here in order to achieve that connection to our ground. We're going to do that through the system bond instead. And again, there's always caveats too to these rules. There's these rules that they want. Then there's caveats. They'll list the rule and then they say, except this rule, this applies in this scenario. Okay, so again, remember to keep reading through the rules because it will tell you those exceptions. And then talk about grounded conductors. Again, how they run. They must be electrically continuous. It is acceptable to splice it, but as long as it's electrically continuous, so like in this picture here, they do have a splice here, or that's not a complete path, but it is continuous electrically. And then it talks about grounding electrodes. Again, electrodes, what's actually in the ground, and bring us to that same potential. Talks about rod electrodes, plates, again, their distances. Chemically charged electrodes, I've never used these before in my life. Seem pretty cool though, actually making its own roots into really dry soil. That's when they use these chemically charged ones. And it says they'll basically grow their own grounding roots, which is kind of crazy. Field assembled electrodes, again, all through going to give you all the distance. Okay, if it's in concrete, we go to table 43. I'll just show you that here quick. I'm not too crazy, hard to read or understand, potentially hard to find. So again, minimum conductor size for concrete encased electrodes. So very specific and easy to not make a mistake. References the rule that applies to it. Based off the ampacity of the largest service conductor. So again, based on these amperages, you're going to pick your size of your bare copper conductor. Okay, so not too terrible on that. Talks about in situ electrodes. Those are electrodes basically that are already there. So sometimes we can use a water pipe that's already buried way lower than we would get with a plate or potentially with our rods. So we can take advantage of that potentially, or a pile or something. Okay, but it gives you all the discrepancies for using that as well. Then it gets into grounded conductor size. So now we know how to do it. What size are they going to be? So 10-114 is going to tell us our defaults. Again, remembering that this is the minimum. Code is minimum. You might do something above and beyond this at work. Could be your company spec, customer spec. Regardless, ours is based off the minimum. So unfortunately, you might have to shelf what you do in the field. We especially find this in oil field more than anything, is they go a little bit above and beyond, sometimes a lot above and beyond. But just realize that when we're doing these, this is based on minimum, okay? And the code minimum is what's going to be on your test. Okay, so it is kind of confusing at times, and they're just saying basically these are the minimums. The reason we can use only a number 6 or number 6 copper or number 411 for aluminum, is that they're saying most of the fault would go back on the grounded circuit conductor, back to the main transformer if there was a fault larger anyways. So they're saying we can use this as our ground without having to increase it to the same size as the ungrounded circuit conductors. But again, lists all the rules, the appendix, go check it out when you're reading through it. Okay, so that's all grounding. You got the objective. Objective 2 starts in on bonding conductors. Again, table 16 is going to be our go-to. Things we want to check out for with table 16 is table 16 is going to do all of our sizing for us. Okay, so table 16 is for minimum field installed system bonding jumpers and bonding conductors. And now it's based on the ampere setting of the overcurrent device or the largest ungrounded conductor, and then it's going to tell you the size of copper, aluminum, or bus bars. Okay, but this is kind of a huge thing here. Because everything's being done from one table, we got to find out, well, in my scenario, am I supposed to use the overcurrent or am I supposed to use the largest ungrounded conductor? Well, rule 10.614 is going to tell us that. Again, this is where we really got to just make sure we're understanding the scenario, reading the question properly so we don't get ourselves into trouble. So 10-614 is going to tell us all the different types. So again, number 1 is based on the size of a field installed system bonding jumper. So that's what it's specifically talking about. Shall not be less than the determined in accordance with table 16 based on the ampere rating or setting of the overcurrent device. So if I'm doing a system bonding jumper, I'm going to use the overcurrent device. Number 2, the size of a bonding conductor installed with accordance with 10.604 at service equipment. Okay, again, service equipment, that's a very specific bonding situation. Shall not be less than that determined in accordance with table 16 on the allowable ampacity of the largest ungrounded conductor. So if it's the system bonding jumper, using the overcurrent. If it's service equipment bonding, I'm going to use the largest ungrounded conductor. Then number 3 says the size of a field installed bonding conductor installed at other than service equipment shall not be less than that determined in accordance with table 16 based on the overcurrent device or the ampacity of the largest ungrounded conductor if we've used an increase due to volt drop. So if you have an increase due to volt drop, if we're just doing a regular bond for anything other than service equipment, we're going to use the overcurrent device. Okay, so that's a huge portion of that rule there. It's getting us to table 16 that we really got to know what scenario we're talking about first before we go to table 16 so that we're using the right column. Okay, and and that goes through basically what I just did. They go through all in all these examples. Yeah, and then this example is a large one, but it tells you which rule, which table, what they're sizing it off of. This example, again, a range. Okay, so this is other than service equipment. Obviously, your range is not part of your service. This one is a heater, HVAC. This one doesn't really say what it is, but I used 3A for these as well too. 3A is basically bonding other than your service, and that we're going to use the overcurrent. Okay, but they'll say bonding conductor based on the breaker, based on the fuses, based on the breaker. Okay, so this actually could be a system, so they could be using the breaker for that, for the system bond. Yeah, that would be 1 here instead of 3A. Okay, then it gets into service equipment bonding, service raceway bonding. Watch out for that. That's where we kind of have an and scenario where we got to make sure that if we're using EMT or rigid and we're just using regular lock nuts, standard lock nuts, we have to have a ground bushing in order to have that that bonding jumper here, so that we're bonding this this service raceway too. Yeah, again, specific for service raceway. It has to have them all. So it says it's important to note standard lock nuts and bushings alone are not approved for bonding the service raceway. Again, just the service raceway. Grounding bushings equipped with a bonding conductor, size with table 16 is acceptable if supplemented by lock nuts. Okay, so we're going to use regular lock nuts and then have that grounding bushing. Again, whether we're using rigid or EMT, that's in your code as well. This example here too, just a heads up. It says later that we, in Rule 12, this is in wiring methods, that we don't have to have a bonding conductor in the PVC. It says we don't have to have one up here, up to the service mast. We definitely should have one here. So they don't have one in this picture. I would argue that if we're, well, regardless, whether we're grounding it here or up here, we definitely have to have a bond going through here to carry our bond. Otherwise, in this case right now, this is not bonded because this should be isolated according to the new code. If it's being grounded here, the grounded circuit conductor, this should be isolated, and then we should have a bond going up here. Okay, so just watch that picture so it doesn't confuse you. Then it goes into bonding it other than service equipment. So basically, fixed equipment, basically any electrical equipment we do that's not part of the service. Okay, it's going to tell you how we can ensure bonding with that. Again, this is 10610 in the code. Whether we're running conduit, okay, it'll tell you can't use flexible liquid tight flex is not good enough. You have to run a conductor in there. It'll tell you all the ways that we have to make sure that we have maintained bonding continuity. Also starts talking about electrical equipment, how we can't have it so that if we remove a piece it affects the bonding for other pieces of equipment. Again, just read through those rules. So pretty self-explanatory. Bonding non-electrical equipment, again, water pipes, gas lines, that kind of thing. We all want to make sure they're brought to the same equipotential as ground, so that they aren't current carrying as well. And answers some of those questions. Goes through the distribution center. Some examples of how to size and go through those. Again, read through, answer the questions to the best of your ability. And yeah, as usual, let me know if you have questions. Again, it's hard for me to read through the whole section and the whole mod and kind of just go through it one at a time. It's tough to sit and just read through this section, but what I would rely on is if you guys get stuck on a concept or a question, even if you have an understanding of why you got it wrong, or you found the rule but you're not quite sure why it's wrong because of the interpretation, definitely just get a hold of me, okay? And we'll sit down and we'll discuss. We'll use some of those diagrams in the back, and we'll go through and make sure you have an understanding. Again, our question bank is really good at providing feedback. So if you get something wrong, check the feedback. It should come up when you submit your test, and it should tell you the rule that you should have gone to and potentially the interpretation of that rule. Okay, but as always, let me know if you have questions.